Among 726 babies born to couples using the H0 method, 402 were girls. Use these results with a 0.05 significance level to test the claim that the proportion of girls born to couples using this H0 method is greater than 50%. So let's start out identifying the claim and write it in terms of mathematical symbols. So the claim in this case is that the proportion of girls born to couples using this method is greater than 50%. So we will use P is greater than 0.5 for our claim. Step 2 then is to identify the opposite. So if our claim was greater than, the opposite of that is less than or equal to. So we would say P is less than or equal to 0.5. Now the third thing to do is identify the null hypothesis and the alternative hypothesis, and then decide which one corresponds to the claim and which one corresponds to the opposite. So remember, the null hypothesis is always the one that has an equals in it. And in terms of our claim or our opposite, the opposite is the one that has the equal sign in it. So we'd say the null hypothesis goes along with the opposite, and our null hypothesis will be that the proportion equals 0.5, which means our alternative hypothesis is the one that doesn't have the equals in it, and that'll be P is greater than 0.5. Now this tells me we're going to be doing a right tail test because our alternative hypothesis is greater than. So we'll come back to this in a bit and decide why we had to, or figure out why we had to decide on this correspondence once we get to the end of our hypothesis test. So step 4, we want to calculate the test statistic for this sample, and you can see I've already got it here, but how did we get that? We used our test statistic formula, plugging in what we know. So in this case, P hat, or my sample proportion, was the 402 babies that were girls out of 726 babies born. So 402 out of 726. P is what the population proportion would be if this H0 method didn't work. So what I'm assuming the population proportion to be is 0.5. You also get that from the null hypothesis, 0.5. So again, Q is 1 minus 0.5, and N in this case is 726. So plugging all this into my formula and throw it into the calculator gets me a 2.89 test statistic. So step 5 is to calculate the p-value for that test statistic. That is, we want the probability of finding a test statistic more extreme than ours. So since this is a right tail test, the p-value will be the area to the right of our test statistic, 2.89. But if this was a left tail test instead, we would find the area to the left of our test statistic. And if it's a two-tail test, well then it's twice the area to the right if it's a positive test statistic, or twice the area to the left if it's a negative test statistic. So in this case, the p-value is 0.0019. So how did we get that? We had to look up 2.89 in our z-score table. That is our normal probability table. So 2.89 got me 0.9981. So 1 minus 0.9981, since I want the area to the right, gives me 0.0019. Step 6, we decide whether we reject or fail to reject the null hypothesis. To do this, we compare our p-value to our significance level, which was 0.05, and since our p-value is smaller than the significance level, we reject the null hypothesis. If our p-value was larger than the significance level, say it was 0.06, then we would fail to reject the null hypothesis. So the last thing to do is to draw your conclusions or interpret the results in terms of what the original claim was. So let's look back at the beginning to figure out how to do this, and remember that we are rejecting the null hypothesis. So this is what we did at the beginning. But notice in this example, we've rejected the null hypothesis. So let me draw a line through there. Notice that the null hypothesis corresponded to the opposite in this example. So since we're rejecting the null hypothesis, that means effectively we have enough evidence to support our claim that the proportion was greater than 0.5. So again, since the null hypothesis went along with the opposite, and we rejected the null hypothesis, we can effectively support our claim. So there appears to be enough evidence to support the claim that the proportion of girls born to couples using the XORT method is greater than 50%.